Welcome you all to the third session of Theory of Relativity of 5th semester BSc. In this session, we are going to study the significance of negative result of Michelson-Morley experiment and postulates of special theory of relativity. He is a man who gave postulates for special theory of relativity. Already we have studied these things, frames of reference, some of the dynamics of a system, and in the last session we worked on construction and working of and observation in Michelson-Morley experiment. Using that thing, we are going to study the results of Michelson-Morley experiment here. Is the same diagram which was used in the last session. A light from the light sources falls on the semi-silvered mirror P. Some of the part of it is reflected along towards the mirror M1 and some of its part is refracted towards mirror M2. After the reflection from the mirror M1 and M2, light will be reflected towards the telescope T from P. Here there will be a fringe shift observed in T when the apparatus was rotated by 90 degree. They were expected some fringe shift, but it was not present. Look at those things. Fringe shift was not observed when apparatus rotated to 90 degree. When the whole apparatus was rotated by 90 degree, they were expected a fringe shift of 0.4 or 4% in their apparatus, but that was not measured. It is impossible to measure the speed of Earth relative to ether, since there was no such medium exist like ether. How can we measure the speed of Earth with relative to that ether? So there was no such medium like ether was exist in the universe. Significance of negative result in the Michelson-Morley experiment are: first one is there is no relative motion between ether and earth. This leads to the fact that absolute motion cannot be detected. Lawrence and Fitzgerald put an idea of length contraction. We'll study about length contraction in the next session. The velocity of light in a space is universal constant. That is called the principle of constancy of speed of light. That is, whatever the observer or the source moving with velocity, the speed of light is unaffected. The velocity of light or the speed of light is always be constant. Speed of light is always c in space rather than c plus v or c minus v. In Michelson, while calculating or doing the mathematics in Michelson-Morley experiment, it was measured c plus v and c minus v. So there is no meaning at all, or there is no significance for this kind of addition. We cannot add any velocity, or we cannot subtract any velocity with respect to the velocity of light. Velocity of light remains constant in free space irrespective to the motion of the source and observer. Special theory of relativity. So here we are going to put another step to know the special theory of relativity, the revolutionary concept that absolute motion is meaningless and only relative motion has meaning. That is, whatever we say for a kinematic of a particle means a particle is moving So with reference to some other point, we can say it is moving with some velocity or moving with respect to another thing. We cannot measure the absolute motion, which is meaningless. According to Einstein concept of absolute mass, according to him, the absolute mass, space means absolute space, and time, absolute time has no significance at all. They will be measured relative to the other things. So on these concepts, in 1905 he proposed the special theory of relativity. Special theory of relativity deals with the problem in which one frame of reference moves with a constant linear relative velocity relative to the another frame of reference. As we said, in whole special theory of relativity, we construct a frame of reference which is moving with a constant linear velocity with respect to some other inertial frame of reference. Whereas in general theory of relativity, we use accelerated frames of references. But here we consider only linear constant velocity relative to some inertial frame of reference. The postulates of special theory of relativity. Einstein frames a two postulate to study the special theory of relativity. The first postulate is the laws of physics are same in all inertial frame of reference, as we seen in the Newtonian relativity. All the physical laws are same in all inertial frames of references. Here also it says that wherever we conduct an experiment to measure something, that will be same in all the inertial frames. The second postulate says that the velocity of light in a free space is constant. It is independent of relative motion of source and the observer. Whatever be the speed of source and observer, it is independent. That is, the velocity of light is independent of those things. So we need to know these postulates with an example here. Look at here. It is impossible to conduct an experiment which measures the motion relative to the stationary ether. No unique stationary frame of reference can be detected. So there is no rest frame of reference. All frames moving with a constant velocity must be on equal platform. Only relative motion can be found and discussed. We cannot say the absolute motion means absolute moment of a particle, absolute motion of a particle is insignificance. The relative motion is only significance matter here. This is the change made by Einstein. The second thing is that velocity of light was not constant according to Galilean transformation. In Galilean transformation, we can add some velocity or a speed to the speed of light, whereas in the second postulate of special theory relativities is that uh, we cannot add or subtract velocity from the velocity of light. That velocity of light always remains constant or invariant in all inertial frame of references. The things which we were studied in this session are reviews on results of Michelson-Morley experiment, significance of negative results of Michelson-Morley experiment, postulates of special theory of relativity with illustrations. Some of the reference books to study special theory of relativity are here. With this, I put an end to this session. Thank you all.